Hello, I'm JW, and today we're going to be looking at that Sonoff switch for the third and final time. And today we're going to find out how much current those solder-covered tracks on the circuit board can take before they either melt, set on fire, or do whatever. So let's get straight on with that. And of course, we're doing this outside. Now, because we're not going to be using mains voltage here, I've had to make a couple of modifications. And the first one of which I've just bridged across the terminals for the relay. And just put a bit of wire and some solder there. And in this particular case, we're going to be sending current through both of the tracks. So I've got the connections on the left there, and the orange and grey wires. That's where we're going to connect our current source. And at the other side, I've just put a loop there. So basically, the current's going to go through one track, through that little loop at the end, and then back through the other track. And as before, I've just taped on the thermocouple bead there with some black tape directly onto the circuit board track, so you can see the temperature of that. And we're going to be using this in the case it was supplied with, so of course that's a more realistic situation. Any heat will be contained within the casing. Now this is the outside arrangement, and I've got the device there just in the front, and various bits of black tape there, that's just to hold the wires and things in position. And on the left side there we've got the timer, so just say how much time has elapsed. The current we displayed on the clamp meter there, that's reading in amps. And the temperature on the temperature meter thing at the back there, that's in degrees centigrade, and currently about 23 or just under 24, as this is a sunny afternoon in August, so fairly warm outside today. So just switch on then, and we're starting at about 5 amps, and bearing in mind this thing's rated up to 10 amps, so that's only about half of its rated current, so you wouldn't expect much to happen there. And see current there about 5.1 or so. And we'll start the timer going as well, obviously, just to give a record of how long this has been going for. So it's been on for just over a minute there, and still at about the 5 amps, and temperature has increased but only to 29, so nothing of any consequence there, and that's pretty much what you expect. So we'll turn up the current now to a more sensible level. So we're up to sort of 9.5 or so there, and see the temperature is now increasing a bit, so that's fine. And this is well within the range of this device. It's supposed to be rated to 10 amps, so only about 9.5, so should be easily able to cope with this for an indefinite period. So we're now about 3.5 minutes in or so, still at the sort of 9.3 or so amps there, and see the temperature has increased to 55, but again that's not exactly a problem because even previous installations rated to 70. So at 55, totally acceptable. And the temperature doesn't seem to be really moving anywhere from the 55 area, so it seems to have stabilised at that kind of level. So certainly up to the 10 amp range, this isn't a problem at all. And again, this is what you'd expect because it is rated to 10 amps, and we're only sort of putting just under 10 amps through there. Now I've turned the current up now to about 11, and this is similar to we had the kettle in the previous video. And in that one we saw the temperature got up in the sort of high 70s, around 80. So as before, we'll just leave this going for a while and see where the temperature gets to. Now we're just coming up to the 8-minute mark now, and current's still around 11.4 amps or so, so this is roughly equivalent to the kettle we had previously. And you see the temperature's around 79 or 80. It doesn't really seem to be getting above that. So again, there seems to be a sort of equilibrium point here, and we've had this current on for a lot longer than the kettle. The kettle was only on for about 3 minutes, whereas this has been on for quite a bit longer than that. So we'll turn up the current a bit further. So now running about 13 amps, and just over 9 minutes in total so far. Temperature has gone up to 94, which you would consider to be an unacceptably high temperature, but bearing in mind this is 3 amps over its actual rating, so 30% overload. Obviously wouldn't recommend using the device at this kind of level. And we're going to leave this on for a while and see just how hot it will get at this kind of current. So 11 minutes in, and the temperature's up to 105. That's certainly hot enough to burn if you were actually touching it. Current's still around the 13 amps mark there. It has dropped away a little bit due to the increased resistance of the wires involved. Now I'll turn the current up here to over 16, and bearing in mind we're now into the gross overload category. This is more than 50% overload of the rating of the device, and as you can see the temperature is of course increasing fairly rapidly. Now we're just coming up to the 13-minute mark, and at this point it's just a question of how far it will go before it sets on fire or something. So we're going to turn the current up to 20 amps, so that's actually double the rating of the device. And as you can see here, the temperature is now exceeding 200 centigrade, and it's still continuing to increase fairly rapidly. Now we're at 14 minutes, and current just under 20 amps still. Temperature is now an unacceptably high 370 centigrade, and if you have a look at the actual device, you see the label on the right hand side is starting to curl up and peel, probably from the heat inside, and there are some bits of smoke coming out of the device. Now temperature is now exceeding 400, and you can see there is smoke now coming out around the connector block on the front there. It's quite windy today, so a lot of that's just being blown away, but nevertheless something is definitely grossly overheating and smouldering away inside. Now you see that the side of the item is actually now smoking considerably, and it's actually melting the plastic on the side of the box as we're coming up to the 15-minute mark. Temperature is now over 660. And you notice that this is the point it's actually failing, because the current now has dropped away to almost nothing as smoke pours out of the device, and now it's actually got open circuit, and you see the temperature is now decreasing steadily. See there's that sort of charred mark on the right hand side of the plastic case. So let's have a look at the thing after the power has been disconnected, and you see the side of the case there has melted and charred quite considerably there. I'll just try and open the casing there. So the two halves of the case have actually melted together, and inside there's quite a lot of black charring, but the main point here is that the case hasn't actually set on fire. It's just sort of melted away into that sort of gungy black mess there. And if we look at the side there, so it has actually just melted the two halves into a single piece. Quite a bit of smoke damage inside the plastic. And have a look at the board here, you'll see that the track on the top there has actually just melted through, and the copper is lifted away from the circuit board material, so it's just the remains of the track sticking up there. Case there, see it's not actually burned as such, it's just more sort of melted and blackened away, which is what you actually want these things to do rather than just burst into flames. So in terms of its performance, certainly up to the rated 10 amps, not a problem at all. The thing only got slightly warm. And even if we went sort of 10 or above, it didn't actually get that hot until we went sort of grossly over the top. So even using a sort of modest overload for a short period wouldn't be a problem. And bearing in mind the damage we've seen here is at double its actual current rating. And even then it didn't actually sort of set on fire or cause things to be combusted in the vicinity. So again, not actually bad at all. And certainly if you're going to use these things up to the sort of 10 amp rating, then it doesn't look to be any problem with doing that. So that's it for the looking at this device, and of course now we've destroyed it, so it's certainly not going to work again. And until next time, thanks for watching.